Hi, hi, hello, welcome and welcome back to yet another episode on your favorite Little's Law YouTube channel. So today in this video we're going to see about the differences between the performance testing and performance engineering, because going forward we're going to see a lot of topics on performance engineering related concepts. So this is going to be a first video where we're going to see the differences between performance testing and engineering. So the reason I'm bringing you this video is to make sure to understand that which track are you in. Are you doing the performance testing or are you doing the performance engineering? And this will also help you to understand what you should do to shift your role or to shift your career or your track of work to performance engineering if you're interested to upbring yourself in terms of your career in terms of performance engineering. So this is going to be more interesting and more informative. So please don't forget to subscribe to our channel for more videos like this, and give a thumbs up if you like this video. Share the video with your friends who you think will make use of it. So starting the first one, the very first thing is the difference between performance testing and engineering. So we're going to see the very first difference. So talking about the first difference, the performance testing. So performance testing is a process which is focused on evaluating the application's behavior under specific conditions. Say for example, it could be a load test where we can where we can emulate heavy user load test, heavy user load, or volume testing using like simulating data processing or resource consumption. So the primary objective is to test the responsiveness, stability, scalability of the application. That's what we are going to do with the type of load testing, like load testing, stability, scalability testing, or stress testing, or spike testing. So using all these, the objective is to test the responsiveness, stability, and scalability of the application. So it typically happens after development. So the testing, the performance testing, yes, it does happen after the development. Yeah, that's what we have to understand, because the reason I'm telling you why it happens after development is the performance engineering happens during the development, which I'll tell you later. So yeah, the performance testing happens after development, which where we simulate production-like scenarios to ensure the application can handle expected traffic and usage. So when I say production-like scenarios, yes, we are going to emulate production-like scenarios, and the infrastructure also will be like production-like, right? For example, you testing a bank application where you're doing a performance testing for a bank application to see if it can handle 1,000 concurrent users making transactions without delays or errors. Right, so that's about performance testing. And moving to performance engineering, so this is a more broader and it's a more proactive approach which goes beyond performance testing, because performance testing, like I told you, it starts early in the design and development phase where we ensure the application is built to meet the performance goals from the ground up, right? So as I told you, it does not start after development or after the changes that has been released. It starts early even in the design and development phase, right? And also it involves optimizing the application's design. So you, as a performance engineer, you have to look into the design, the architecture, the code, so that you can enhance the responsiveness, the scalability, and efficiency. So for example, while developing the same banking application, the one we have discussed for performance testing, so the same bank application, the performance engineer, so if you are a performance engineer, you make sure that the database is optimized for high volume transactions and the server is configured for scalability. So the key difference here is performance testing is reactive and it verifies the application's performance after it has been built, identifying the issues that need to be fixed. On the other hand, the performance engineering is proactive. That's why if you are in a performance testing team and you're pricing meetings, your manager might ask you like, what is the proactive measure that you do? So this performance engineering is such a proactive thing where it aims to prevent the performance issues by designing and optimizing the system for high performance from the start. So by combining both the practices, you as a team can deliver applications that are robust, efficient, and ready to handle real world demands. We'll move on to the next difference. Yeah, now moving on to the second difference. So performance testing is a distinct QA process, different quality assurance process, where we perform a specific round of testing after the development is completed, and its purpose is to validate the application's performance under predefined conditions like heavy load, heavy user load, or high data volume. So typically, performance testing happens after the application is built or when a new feature is added. And this is to ensure that the application meets the expected performance standards before moving to production. And say, for example, after completing a new feature in an e-commerce app, a performance tester simulates user traffic to ensure the app can handle increased loads without slowing or crashing, without slowing down or crashing. On the other hand, the performance engineering, like I told you in the very beginning, it's a proactive approach. So please always remember that. So that's why even it comes here as well. So performance engineering is a continuous and a proactive process which spans the entire development life cycle, right? And it begins in the design phase where performance goals and metrics are set and continues through development and testing. So the focus of performance engineering is on optimizing the design, the architecture, and the code of the application to meet performance requirements from the outset. So somebody, there are like a few of our subscribers might ask me that, okay, do I need to learn coding for performance testing? For performance testing, you do not need to learn performance testing, but for performance engineering, yes, you have to know how the design works, how the architecture works, and how the code works, right? That will help you to equip yourself for a better performance engineer. And so while designing, say for example, okay, while designing the e-commerce application, the performance engineers ensure that the database queries are optimized, the server infrastructure is scalable, and the code is efficient to handle peak traffic smoothly. So now we'll move on to the next difference here. So now in this difference, I'm going to explain about the role. I mean, previously we discussed about the performance testing as a concept, but now I'll tell you about the performance tester. I mean, the one who does all this testing. So the performance tester or dedicated testing team is responsible for conducting the performance testing. Yes, we all know we as a performance tester will do all these testing process testing activities, and we specialize as performance testers specialize in tools. When I say tools, it can be load runner, near load, JMeter, K6, Gatling, Locus, or whatever tool. Techniques, when I say techniques, it can be like correlation, parameterization, writing JavaScript code for custom code and all these, and methodologies which are required. So when I say methodologies, like thinking about the workload modeling, thinking about the think time, the pacing, so all these methodologies. So as a performance tester, you are required to evaluate the application's performance by using all these tools, techniques, and methodologies. So the key responsibilities of the performance testers are, as a performance tester, you should design and you have to execute the performance test cases. You have to operate the performance testing tools like JMeter, LoadRunner, K6. You have to analyze the results to identify the performance bottlenecks, and you have to report the issues or any defects to the development team for resolution. Say, for example, a performance tester uses JMeter to simulate 1,000 concurrent users who are accessing a website and analyzes the results to determine if response times meet expectations. And coming back to performance engineers, so what does a performance engineer do at the same situation? So a performance engineer has a broader skill set. Yes, as a performance engineer should also have the skill set of a developer, should also have the skill set of the performance tester, of infrastructure engineer. So it's again a combined role, I would say, because he plays, a performance engineer plays a more proactive role in optimizing the application's performance, and the performance engineer's expertise spans across multiple areas. Like I told you, the application design architecture, where the performance engineer has to ensure the system is designed for efficiency and scalability, and writing or optimizing code for better performance. Yes, you have to write, you have to understand the existing code, right? And you have to be ready to optimize the code. And the performance tuning and optimization, so you have to fine tune the databases, the servers or network settings to improve the efficiency. And when it comes to root cause analysis, yes, as a performance engineer has to investigate the underlying reasons for performance bottlenecks, and fixing bottlenecks is proposing and implementing solutions to resolve performance issues. So overall example, I would say, as a performance engineer, you should identify that a slow loading page is due to inefficient database queries and optimize the queries to reduce the response time. So this is a quick example. As a performance tester, you will tell what happens, but as a performance engineer, you should optimize the query to reduce the response time. And now we'll move to the next difference. So still we are on the performance tester and the difference between the performance tester and the engineer. So in a bottleneck, say for example, when a point at the application's performance slows down or fails, so it is identified, if it is identified during performance testing. So the performance tester role is to analyze the results to understand where and when the issue occurs, and he has to document the findings and raise a defect in the issue tracking system. And also a performance tester has to provide detailed information about the issue, such as the conditions which it occurred, like for example a high user load or the metrics affected like response times, the CPU usage. Say for example during a load test, a performance tester notices that response times spike dramatically when the number of users exceed 500. So they analyze the logs, confirm the bottleneck, and raise a defect for further investigation. On the other hand, the performance engineer, yes, it begins after the bottleneck has been identified and logged, but still they have to investigate the root cause of the issue by looking into the application's design, the architecture and infrastructure, and the performance engineer will perform a detailed analysis of various components like code, database, server to pinpoint the exact source of the problem. So when I say pinpointing the exact source, so once the root cause is identified, they have to propose and implement solutions to fix the issue and optimize the performance. Say for example, after reviewing the defect raised by the tester, the performance engineer discovers that the bottleneck is caused by an inefficient database query that does not scale well with increasing visual users. So they write the query to make it more efficient by resolving the issue. So in fact, where we have discussed about different database related issues and how it was fixed. So if you haven't watched it, please do watch those videos as well. Now we'll move on to the next difference. So let me now take you through the other difference between the performance tester and engineer. So the primary focus of the performance tester is on observing and analyzing the application's behavior under load. So because of that, they do not delve into the underlying design architecture. Yes, as a performance tester, even we do not have access to understand the design architecture, and only when you press or when you talk to the lead and to the respective person, only then we can get access to. But as a performance tester, we don't normally get access to it. And once you believe that you get access to that, so you are actually growing yourself as a performance engineer. So this role, I mean the performance tester's role, is to execute load and stress tests to see how the application responds under varying conditions. And also the performance testers have to measure the key performance metrics like response times, throughput, and resource utilization, and have to identify the performance issues or bottlenecks based on the test results and raising them for further action. So an example, I would say like a performance engineer who is simulating 1000 users who are accessing a web application simultaneously, and the performance engineer has to note down the response times, which becomes unacceptable after 800 users. So they report the issue without necessarily investigating why it happened. So now you can understand the difference. So the performance tester finds the bottleneck or finds the issues, but they don't necessarily investigate why it happens. They see what happens, but they don't really bother about why it happens. And if you are really bothering about, and if you're really proactively trying to fix it, then you are a performance engineer. So let me explain you that. So the performance engineer focus is a much broader and deeper. So they're concerned with how effectively each component of the application performs under load. And the performance engineer responsibilities include evaluating and optimizing the design and architecture of the application to ensure the performance goals are met. And the performance engineer has to monitor the performance of individual components like databases, the APIs, the servers under load conditions. And also he has to identify any inefficiencies or bottlenecks and implementing solutions to improve the overall system performance. Say for example, after identifying that response times degrade beyond 800 users, like the one the performance tester has found previously. So after identifying the issue, the bottleneck, the performance engineer has to examine the architecture and discovers that the database query is inefficient. So in this example, I'm taking through all most of the things through databases, because databases plays a main role in terms of the performance. And the performance engineer optimizes the query, or he can recommend changes to the database schema. And that's the difference in terms of the performance testing and engineering. So now we'll move to the next difference. So now we'll see what happens when the performance tester identifies the bottleneck. So what does a performance tester do? So when the performance issues are discovered during the testing phase, it typically means the application has already been developed, and fixing these bottlenecks at this stage often requires additional resources, time, and money. So the reason for higher cost is developers need to again revisit the code, which can delay the project timelines, and the changes may require reworking parts of the application's architecture or design. And any new infrastructures or tools might need to be introduced to address the performance issues. Say, for example, if a database query is found to be inefficient during performance testing, so fixing it might require significant changes to the database schema, which could disrupt other parts of the system and require additional development and testing efforts. So a well-tuned application designed by a performance engineer, in contrast, like the previous part which is done by the performance tester. But on the other hand, if a performance engineer faces it, or if a performance engineer is in that situation, so if a performance engineering is integrated into the design and development phase, the potential bottlenecks are addressed early on. So this proactive approach ensures the application is optimized from the start, avoiding costly fixes later. So the benefits of early optimization is to reduce the need for rework, which saves time and money, and you're on your project timeline, you're on the right timeline, and the application is built with performance in mind, which leads to fewer surprises during testing, and the resources are used more efficiently as changes are less disruptive when made during the design phase. So for example, a performance engineer reviews the application design and ensures database queries are optimized during development. So as a result, the application performs well under load and no expensive fixes are needed later. And now we'll move on to the one last difference. So now we'll talk about the performance testing lifecycle, which we call it as PTLC, which is specifically focused on the performance testing process, and it covers all the key phases which are needed to plan, execute, and analyze the performance test. So it starts from requirement gathering, where we understand the performance criteria like the response times, throughput, scalability, and test planning, where we define the test strategy, tools, and environment setup. And when it comes to test design, we create test scripts and scenarios based on user behavior. And when it comes to test execution, running tests to simulate load, stress, or endurance conditions. And when it comes to result analysis, we review metrics to identify the bottlenecks or performance issues. And finally, when it comes to reporting, we document the findings and provide recommendations for improvement. So during the performance testing lifecycle, the PTLC, a tester simulate 1,000 users accessing an online store, where we analyze the server response times and where we report slow loading pages as defects. And moving on to the next part, which is performance engineering lifecycle, the PELC. So PELC is a broader and more comprehensive approach that encompasses all the engineering activities which are related to performance from the application's inception to deployment and beyond. So we talk about the design phase, where we incorporate the performance goals into the application's architecture and design. And when it comes to development phase, we write efficient code and perform unit level performance optimizations. And when it comes to testing phase, we conduct performance testing, the PTLC, and refine based on results. And moving on to optimization and tuning, where we address the bottlenecks, fine-tune the system components, and ensure scalability. And when it comes to the final part, which is monitoring and maintenance, where we monitor the application in production to ensure continued performance under real-world conditions. So far, we have discussed some of the key points which will help you to understand the difference between performance testing and engineering. And if you think there are many more points to add, feel free to share them in the comment section below, and don't forget to like, subscribe, and hit the bell icon to stay updated with more insightful content. And your feedback and ideas are always welcome. Let's keep the discussion going. So to wrap up, I would say that a performance tester with strong testing skills can become a great performance engineer, even if they have, when they have a keen interest in bottleneck identification, root cause analysis, and application tuning. However, to excel in this role, they must always have a solid understanding of the application design and architecture, because that's the combination of skills and knowledge that sets apart the performance engineer. And I wish you all the very best. Please don't forget to subscribe to our channel, and please do watch for more informative videos like this. Thank you, and see you all in the next video. Take care and bye-bye.